SOA introduction. SOA is an evolved programming model for business, service-oriented architecture, in fact, right? So this is the precise intro to evolution of programming. In 60s, high-level languages such as COBOL, Fortran evolved. Compilers were common tools for programming. Jump, go-to kind of statements were common in programs. The side effects of all these things, ripple effect in code that we used to call that problem, as code was highly coupled and least cohesive. Therefore, further evolution was needed. Then, the evolution in 70s, structured programming, like C, Pascal languages were evolved. Code reusability through functions was one of the breakthrough, but functions were tied to data. There were some problems that still remain. Still, code was coupled and not much cohesive, needed further evolution. In 80s, object orientation, that was a quantum shift from structured programming to object orientation. Languages C++, Smalltalk, Ada were very popular languages at that time. Abstraction and inheritance was the common achievement that particular model achieved. Code was less coupled and more cohesive. In fact, reusability was also better. But interoperability, integrations were still some problems still there in object orientation. Then the evolution continued in 90s. Component-based programming model evolved, where we had libraries, static libraries, dynamic link libraries, DLL were common. COM and CORBA were the platform where we had component programming. Code was less coupled and highly cohesive, but interoperability was very, very complex. Then there was still a scope for evolution. So in 2000 onwards, the web services were very, very common, and that was the start of service orientation. XML and SOAP were common protocols for message or data exchange, right? So the most known issues like ripple effect, coupling, cohesion, integration, interoperations are solved in SOA, meaning service-oriented architecture. Service-oriented architectures is highly cohesive and least coupled code which is easily interoperable and discoverable. So in simple words, we can say service-oriented architecture is a business facilitator. It's not only a programming model, it's a business facilitator. Let's see how it facilitates the existing business. So SOA as a business facilitator, how? In service-oriented architecture, everything revolves around services, and services are loosely coupled code. So one of the breakthroughs, the coupling is now much loose, so we have more independent modules and services. Contracts. SOA services provides contracts. So through contract, we adhere to service level agreements. That was unlike in our previous models. Autonomy, control of business logic. The full control of business logic services encapsulates. web services or any other kind of services, we have business logic, right? So that business logic has full control in SOA. Abstraction, definitely the services or web services, anything you call, hides business logic from service consumers. Reusability. We can divide business logic into reusable services. So of course the reusability is still maintained, and in fact it's improved. Statelessness, one of the objectives of the modern programming. That is the minimum retention of info specific to an activity, because the services are used and the information required by the consumer, right, that are not saved in fact. So it's independent of activity or the consumer action. Discoverability, self-described so that they can be found and assessed or accessed, right? This is one of the most important feature of the SOA. All the services are self-describable and they are accessed through some mechanism from consumer to the service provider side. So this discoverability is one of the achievement which SOA has as far as business facilitator, as a business facilitator as concerned. Right. So this is how we can say that service-oriented architecture is a business facilitator, or simply SOA is business. How the service-oriented architecture meets the computing challenges. Computing challenges, primarily processing power, compute, memory, storage, networking, communication, of course, energy, power, environment, pollution, business, material, humanity, social aspects. All these aspects are computing challenges. Right? So let us talk about the compute, how SOA solves this problem. Right? So there is a term called cloud, which is most abusively used, and in fact that is nothing but it's the outcome of SOA, service-oriented architecture, where we have everything provided as a service, whether it is processor, the memory, or maybe the secondary storage memory, or you have some other types of memory, or whether it's networking infrastructure like bridges, your gateways, your backbones. All these things are provided as service, or simply in terms of cloud we call it infrastructure as a service. So we don't have to keep desktops or maybe big servers at small business or maybe mid-sized business locations. All these things can be shared or can be rented out. So that way, if somehow we can provide the compute, storage, networking as a service, it's an achievement, and that is what exactly this SOA has given. And we have a thing called virtualization. Through virtualization, we can have processor, we can have memory, we can have our network as service. Right? So this IaaS, that what we call basically is infrastructure as a service, is one of the outcome of service-oriented architecture, where most of the businesses now simply providing infrastructure. They are providing rack servers, they are providing big storage, They are providing good networking infrastructures, and the users of the consumers, they don't have to worry about their networking problems, storage problems, compute problems. They can simply have a kind of agreement with the infrastructure service provider, and they can use that infrastructure. Then it comes to the energy as a challenge in computing, right? If the things are distributed, we have processors, storage distributed across the globe, right? We have multiple CPUs, multiple desktop, multiple power supplies, maybe power backups, right? So there is a simple calculation. 1 watt of processing power takes 30 watts of actual power. Reason? Because we have other infrastructure. Power backup, we have UPS, we have SMPS, we have monitor, we have some other peripherals which consumes power, right? If we have that processor or the CPU as a service provided by some service provider, we can reduce the number of peripherals we require and power will be saved. So this is energy aspect which SOA means in fact. Environment. Pollution, that again, if we have multiple CPUs, multiple desktop, multiple servers running across and maybe utilized 1%, they consume power as well as produce CO2, carbon dioxide gas, which is the main cause of environmental pollution. So through SOA we can reduce the carbon footprint as well. Material business. Now what SOA gives to business? Businesses, whether it's small business or big business, they don't have to think about infrastructure. They don't have to think about platform. They don't have to think about softwares. What they have to concentrate on is simply the business, what they are giving, the application which they are giving, the business logic, the application which they are into, right? So that way definitely businesses, the material as a challenge is one of the achievement in SOA architecture. And the last but not the least, the humanity, how the humanity is related to the computing. Social networking or socializing is one of the achievement again, because the day is not far when people will have marriages online or on clouds, because we will have everything so close that we will have every kind of social gatherings on the cloud, and that is only through SOA, service-oriented architecture. So these are the few challenges, computing challenges, which SOA is definitely targeting, and SOA is definitely